Craig Beckman, CEO of Aqua Membranes, discusses how the company has worked with Micron to provide its row elements with printed spacer technology as an alternative to standard row elements with mesh spacers. A pilot water treatment trial has demonstrated significant energy savings as well as operational benefits for the semiconductor manufacturing company.
Okay, so it'd be good to understand to start with how Aqua Membranes and Micron, how you got together. What did they come to you with a problem and ask you to help, or yeah, just the background to the beginning of the relationship?
Sure. Yeah, Micron approached Aqua Membranes about 2.5 years ago now. They saw us pitch in a competition accelerator program, and it was specifically around sustainability, and that's a big driver for Micron, as well as lots of big industrial customers now, this idea of net zero, or at the very least less. Micron specifically, like a lot of chip manufacturers, is under pressure from their customers. So Micron is a memory chip maker. Most of the buyers of memory chips are data warehouses, and the data warehouse, both owners and customers, big, I think Amazon Web Services, are putting pressure on all of their supply chain of, hey, we've got to do better. And so Micron looked through their entire manufacturing process, from utilities to actually chip manufacturing to tool selection, and really tried to be intentional about how can we cut electrical, chemical, and water use in all of those areas. In water specifically, they looked at, they told us a couple hundred water technologies, chose Aqua Membranes as they felt that we had the both shortest path and biggest impact, kind of optimizing those two things together. So they approached us and said, hey, we'd like to work together and utilize your technology in our fabs. Microelectronics is a industry that is slow moving to make change. So we are now only about halfway through, even after 2.5 years, our evaluation, ramp up, growth into their business. So we are running at a Micron fab now, but as I said, we're still not at nearly the rate at which they would desire to really get the big impact from sustainability, and very specifically measuring energy reduction to make the same quality and quantity of water.
Okay, so yeah, involved with them, I don't know how much prep work you had to do, but the end result, I believe you've established a pilot trial with them. So, and I understand there might be confidentiality, but if you're able to tell us as much as you can about how you went about setting that up, and even what's gone on to date, if you can.
Yeah, like again, many industrial customers, and maybe microelectronics more than most, confidentiality is super important and critical. So I will share what I can, mostly what Micron has already shared through press releases and other presentations we've done with them at Semicon West, for example. But yeah, we're running at their fab in Boise now. And what they wanted to do was really do a comparison to prove the value and to validate the savings that we could get. We'd done that already in lab settings in a number of different formats as kind of the beginning testing before we went into the fab. We went into the fab in Boise this spring, and they have there a machine that actually got 2 identical trains. So it was the perfect environment to test old against new. And we swapped out membrane elements in both sides at the same time, and then started collecting data. And they collect a lot of data. They collect, I think, about 12 different operating parameters on each machine every 5 minutes. So we have troves of data, and we've been tracking it and monitoring it together. Twice a month, the teams get together and look at the data, make the adjustments, still make sure we're on track, see how much savings we're actually getting. And there was really 2 big savings or advantages that we brought to Micron through the entire trial as recently as Monday this week. We had another call. And the primary goal was energy savings. So what Micron is doing is running the output of both trains of that machine set at the same number, and then measuring the energy they have to put in to make that output. And then also a critical parameter right from the beginning was the output has to be the same from both a quality and quantity standpoint. So they can set the quantity with pumps and variable frequency drives, but the quality of that output they measure, and they make sure that it's there. Because if we couldn't make the quality of water they need, then they won't even evaluate to see if we can get the energy savings. So number one, we make the same quantity, same quality. Then over time, they're measuring the reduction in energy that is available with our technology. And that's been about 18% when we started. And now we're up to almost 20%. And that's because a secondary benefit that we both planned on or hoped for, but was tough to do without actually running in the field, is this idea of scaling and fouling. So membrane elements are very, very small pores, sub-micron kind of sizes. And it's very easy for particulate matter, colloidal matter, precipitated salts to block up those pores and slow down production. That's typically measured by pressure drop from the beginning of the system to the end of the system. With this idea is your system builds up more solids in it. It has more pressure drop, harder to get the water all the way through. And so as we're monitoring pressure drop on these two trains, one with old, one with new being us, there's actually been a meaningful increase in the old technology that we haven't seen in ours. And that's where we get this idea of, well, we started at this much energy savings, now we have more, which is a huge benefit to Micron. But maybe even more interesting is that that's also a good proxy for the life of the product. Usually membrane elements, whether they're used in home use or microelectronics or seawater desal, they are replaced when that pressure drop gets too big. So when you can no longer push water through or it gets too inefficient, then it's more cost effective to take those out and put new ones in. And depending on the application, maybe it's a year on really challenging high fouling applications to maybe as year as 6 to 8 years in some really clean applications. But at the Micron pilot so far, we've actually been scaling and fouling the printed spacer technology much slower. And so that's a secondary benefit that Micron continues to track. So we get those kind of primary goal of energy reduction we monitor on a regular basis, and then the fouling scaling reduction, which leads to, hopefully into the future, longer membrane life and a slight increase in that energy savings that happens over time. Next for Micron, as you'd expect, is, all right, you run for a certain amount of time at this fab, and then we go to another fab or a bigger application. And that's kind of all of this longer term rollout plan we have with them.
Okay. And in terms of the actual technology, yours is, I think it's printed spacer technology. So is that a direct replacement for traditional reverse osmosis sort of mesh architecture? You're not augmenting something already. It's a brand new, it's a rip and replace type solution. Is that it?
Exactly. Yeah. So membrane technology, there's kind of two big components. There's the hardware that companies like Veolia or Ovivo or Carita would supply. And then the membrane elements inside, those are actually shown in the background I've got on my screen here. Those are the disposable membrane elements, come in two standard sizes, 4 inches in diameter, 8 inches in diameter. So what Aqua Membranes is producing, yes, is a direct retrofit 80-40 element, same exact dimensions, 8 inches in diameter, 40 inches in length. So if a customer has an RO system today, it'll have some number of housings. If it's a small application, they might have 5 or 6 housings. Some of the large seawater plants run into the tens of thousands of housings. So it really runs the gamut. But in both sides, they have that same standard 8-inch element. That's exactly what we are making. Some people kind of get it a little incorrect in the market that they assume we take a standard element, unroll it, print it, and roll it back up. But that's not actually what we do. We start with large rolls of membrane before they're put into element form, unroll them, index them, print them, and then roll them up into a finished element. So our manufacturing process looks very much like others in the industry. Start with a roll of membrane, end up with a spiral wound element that's got the different layers in it.
Okay. And in terms of what you've done for Micron, have you done anything bespoke for it, or is it a standard product that you've installed for them and are now trialing, or if you had to modify it in any way, shape, or form for them or not?
For microelectronics specifically, the difference in our product for that industry is really the same as other industries. So our big innovation is this idea of taking out the material that was in the flow path. So membrane elements for 50 years now have been pretty much manufactured the same way, with this mesh extruded spacer layer in between each layer of membrane. And that's where the water would flow. It's an extruded kind of fencing mesh type material, create some turbulence, but also can create a real fouling and scaling ladder or matrix, if you want to think about that. That's what we take out and instead put a printed spacer feature right on the membrane surface. What changes a little bit industry to industry, and this is where we definitely get into some of the stuff we can't share, but the patterns that we create are customizable. And so we do have slightly different patterns for different industries. Today our pattern is primarily focused on high purity water. And so whether it is a power plant running high purity water or a food and beverage plant looking for high purity water for bottled water applications or semiconductor rinse water, that's pretty much the same pattern. But as we move into other areas of seawater desal, or we move into, for example, we did an application for a food concentration, another customer that's not public, but there's a really different application where we're concentrating sugars, and concentrating sugars are very different than making high purity water from Micron. That definitely is a different pattern. So it's one of the benefits that we're excited about with our technology, that because we're customizing and printing those technologies or those patterns on a case-by-case basis, it's relatively easy to change them. And so we can optimize for different applications and different customers. Today we're pretty laser focused on microelectronics and high purity, with some other applications and products coming soon.
Okay, and in terms of, I know you can't necessarily share too much more. We say the next step is maybe a bigger fab or whatever, but have you sort of sat down and done the maths, or have they, the potential, if it's, this is rolled out across all their fabs in terms of the energy savings and the perhaps the less downtime, or that they don't need to replace membranes, for just how big an impact do you think you could make for them?
Yeah, that's a difficult one. We know exactly what the number is, but it's obviously something I can't share. Let me,
it's substantial, no?
Yeah, let me kind of summarize it this way. So when Micron first did their investment in Aqua Membranes, they did it actually right before their annual sustainability report came out. So that was April timeframe, and it was a really good coincidence that they got done with their diligence and closed the deal right before that point. So they highlighted us in their sustainability report, both the first and second year. That was 21 and 22. And I would say that early days of the investment, it was probably more focused, if I'm honest, on sustainability, and it was a good metric. But it wasn't something that maybe moved the needle for a company the size of Micron. And I would say that now that we've gotten more into the testing and the results are looking better than we thought, we are getting into the point now where we could potentially move the needle for somebody as big as Micron. So yeah, that's exciting to be in. And I also think it was a little bit of Micron saying, look, there's a lot of new technologies come out with lots of big promises and big numbers, and especially in our business, the membrane business. I've been doing this for 3 decades now, and there's a history in our industry, unfortunately, of products that work really well for a couple of weeks or even a couple of months, but then just that high productivity, that high efficiency that they were offering, kind of just that fell down to the mean, and it wasn't that different. And perhaps that was a little bit of Micron's concern of, well, yeah, I mean, their lab testing looks great, their early pilots look great, but let's see if they really keep that level of savings up over time. And if we do, then yeah, it becomes a very significant number for Micron or any other customer that runs a lot of membranes like the semiconductor industry does.
And with their your sort of close involvement with them, if the technology is working as well as it is, the next step would obviously as well be to try and roll it out across the wider industry. Is there any restriction as to you've got to stay with Micron for a while, and then at some stage you're able to go out to the wider world? Just anything you can share on that?
No, I mean, that's actually been a nice blessing of working with Micron. Right from the beginning, they were focused both on themselves and improving their own metrics on sustainability, but as well as the broader industry. So they've actually been really good. I've worked with a number of other strategics, both at this company and others in my career. And it's rare that, in their industry, they're actually promoting it to other players, even competitors. But I've seen Micron do that. They're, helping us, even making introductions, to other technical groups and venture groups that are in the industry with the idea of, hey, if it's good for us, it's good for everybody. It's good for the environment. It's good for the world. Let's help out. So yeah, that's been really helpful. To be honest, we're still a pretty small team. And so part of it's just, we just don't have the manpower yet to cover all the potential bases. And it's also an industry that tends not to want to be the serial number one. The microelectronics industry is always, well, somebody else better have done it before we do it. And then even in that industry, it's, well, which other ones did it? So an Intel or a Samsung or a TSMC isn't going to do it until somebody else does. And that's been another big benefit of Micron as an investor and an early adopter, and really somebody that's committed to that sustainability metric and doing things different has been helpful, because now we do have serial number one. And that's important for other sites inside of Micron's manufacturing footprint, as well as other competitors.
Yeah. So again, with the, I mean, are you having sort of conversations and planning with various other companies, or are you going to wait to get to a certain stage with Micron and then it's easier to move across? Just anything you can share as to where else?
Yeah, I would say that we're in early discussions, probably about as much as we can share at this point with others. We don't have any installs yet with other semiconductor manufacturers, but we're also not waiting. We're actively engaged on a number of fronts.
Okay. And you've explained during the answers other industries, but I mean I've got two hats on today actually, because I work in the water industry and the semiconductor industry, so this is a sort of perfect marriage.
Yeah.
But in terms of the other spaces, I mean, is reverse osmosis, are you doing a lot with sort of seawater and stuff, or is that a big part of what you do, or is it more specialized, as you say, sort of high purity?
We've got the industry cut into about 20 different market segments. There's a lot of different ways you could cut the membrane industry, but that's just how we chose to cut it. And we've chosen to pick 3 or 4 we'd call beachhead markets, with maybe 1 or 2 as the next interesting places to go. Semiconductors definitely on that list because of Micron. Water reuse is another one, both industrial and municipal. We're seeing more and more customers look, I've got wastewater coming out of the back of my plant. That's expensive to treat. New water is expensive to get, often sometimes not available. And just, consumer-driven expectations of getting better with the water you reuse again and again. So I would say that both in the municipal front and the industrial front, anytime we can put technology on the back end of a plant to get more water back in to get reused again, even for a secondary source. If it's a food and beverage plant, we can take that wastewater, get the sugars out, and then reuse the makeup water for cooling tower makeup or irrigation or floor rinse water. There's usually not always, but usually someplace else to use that water. So that's a segment for us. Food and beverage, any consumer, kind of big consumer brand is, definitely taking sustainability very seriously. And just like Micron, looking at their manufacturing footprint, their utilities, their processes of how can we do more with less. So gaining some traction there. And then the last one wasn't really on our radar, but it's come up kind of just out of necessity, and that's the mining space. In general, the mining space has been more about water retention, bigger tailings ponds, not a lot of what we would call high purity water and separations, but lithium is changing all that. With the drive globally for more and more EVs, almost all of them are driven by lithium chemistry in the battery. Lithium is only in a couple places in the world, and it is definitely a concentration process. It's done a number of different ways, but membranes are very often one of those unit steps. So a membrane element that's more energy efficient, that's more productive. Been contacted by more than one mine with this idea that we've got X amount of hardware, it'll process Y million liters per day, and we have to have 20% more output, which is either more hardware we have to wait for, or if somebody makes a more productive element, let's put them in there. To be honest, some of those have been large enough that we weren't able to actually fulfill the order. So that's why we're trying to ramp up our own manufacturing to catch up with industry demand. But I would say those are kind of our beachhead markets. lots of other potential markets out there. Seawater desal is an interesting one, and probably one we'll have to put more attention to sooner. We were just awarded a global innovation prize by the country of Saudi Arabia for the potential of our technology in seawater, where even 0.5% energy savings gets the industry's attention, and we're going to be significantly above that. Probably not to the 20%, which is some technical reasons on how they bank the systems, but definitely we'd be able to take a chunk of energy out of the seawater segment. So yeah, thinking about how do we go there, how do we build capacity there sooner as well.
And in terms of go to market, I guess you've got two things to do. You've got to work with end users so they understand the benefits of technology. But as I think you alluded to earlier, reference Veolia and I guess the process plant folks. So you at the same time as you're working with Micron, you're also working with some of the folks that supply the process plant to explain the benefits as well. How do you get that balance, or what is that balance, if you like?
Yeah, trying to do both. Right now, kind of the short-term goal for the company is to get as many field installations done as possible in this kind of first 6 to 12 months after we've begun production, which was second quarter of this year. So we're really, even though we've been at this for 10 years, trying to perfect and commercialize it, we really just went into full production second quarter of this year. So over this first year, the idea is to get as many proof cases out in the industry as possible to really validate in the field what we're getting at Micron. This has been hugely important for us to kind of put our money where our mouth is, if you want to say that, of, hey, this is an innovation that works, delivers the value on paper, delivers the value in the lab, and that's then repeated in the field and maintained. So that's kind of an important first step for end users. And because we're retrofittable, it's easy to do that in end users. In parallel to that, we do talk to OEMs. We made it public actually just about a month ago. One of our newer investors is Kurita. So Kurita is an OEM based in Japan that does a lot of great water and wastewater recovery and pure water work in the microelectronics space, as well as some others. But yeah, we've kicked off a program with them. Pretty much everything we're doing with them is confidential. But you can kind of do the math and look at even some of the data we've made public and start to look at machine design a little bit differently. So there's an amount of benefit that we can offer an end user who already has a system. But if we can be involved in the system design before it ever goes in, there's even more benefit that's possible. And even some really unique design changes that weren't and aren't possible with today's technology. So I would say we're at the beginning of those discussions with OEMs, and they're pretty limited at this point. Just again, we're not a big company yet, so we have to kind of pick our battles. But there's some discussions ongoing, and it'll be late next year probably before we see much of that. Specific unit was designed with our technology in mind, and now is in the field operating. But that'll be a kind of dual sales channel for us probably for a while, of end users that want to swap out, get the energy savings or the lower scaling fouling potential, and then new OEMs that are building systems that are designed around the technology.
Yeah, and I'm wondering, if it's a silly question, apologies, but can you foresee a time when, whether it's for the semiconductor or microelectronics or another industry, you partnered with an OEM to design a sort of joint solution that you then marketed to the whole industry, or do they tend to build fairly general tech they wouldn't necessarily build something specifically?
It's a great question. I think it's definitely something that will happen sooner than later. Very often bids are done these days, not so much in North America semiconductor, but certainly in Asia, and very much so in the desal space and a lot of the water reuse space, where it's a concession contract, where the end user isn't buying a specific unit operation. Instead, they're signing a contract over 5, 10, 20 years, this volume treated to that level, either for our use and consumption in the plant or discharge and recycling, whether it's water or wastewater. And if you're designing in that concession world, for sure, a better mousetrap is a good way to win the bid. Our industry tends to be somewhat commoditized. Reverse osmosis membranes have really great performance compared to where they were when I started in the industry, but from each manufacturer, there's not a big difference. And so if the technology at kind of the heart of the separation is similar, that means that the equipment and the concession contract tends to be similar unless you have a different kind of operational technique or cleaning technique or utilization of energy. So our technology offers those OEMs one more tool in their toolbox to make a differentiated product and potentially really differentiate their offer if they're looking at life cycle more than they're looking at the capital price.
And I guess you must be quite excited because you've got the twin benefits, if you like. You've got the energy savings, which is significant, but also this sustainability piece. Obviously, the world and everyone is heading in that direction at varying speeds, and every industry knows. So you've got that. So you've got the sort of both bases covered. So that you must be quite excited about the future.
Yeah. I've been in sustainability for about a decade now. The last startup I was at was green chemistry, on-site generation chemistry, and now Aqua Membranes with a sustainable technology. And I would say in the last 10 years, I've seen certainly a lot more attention in sustainability. And at least in the last year or two, customers really actually starting to spend more money for sustainable solutions. 10 years ago, everybody wants to be sustainable, but only if it's cheaper. Well, yeah, that's kind of a no-brainer. That's, like apple pie and puppies. Everybody loves it. But the challenge as a technology innovation company and entrepreneur is coming up with something that's sustainable, that's actually cheaper. Because if it's both, it probably would have already been done. So today I'm seeing more of that. Look, we will spend a premium, not a big premium, but we will spend a premium on sustainability. But kind of those great kind of unusual technologies where you actually do get savings and sustainability, now we're going to get even more momentum because the customer is willing to pay a premium, but if they don't have to, they wouldn't, obviously. And so, coming back and being able to find a technology that does both, it's exciting. And we're in an enviable situation, I guess you would say. We have a lot of customer demand, but not enough production yet. So we're ramping up as fast as we can.
Okay, we covered some good ground and some brilliant insights into what's going on. So, Craig, I really appreciate your time.
Oh, sure.
Thank you.
Yeah.
Thanks very much.
My pleasure. Nice meeting you, and appreciate the time.